Good evening students. In this segment of electrostatics, I am going to explain you the basics of electric field. So before starting the electric field, I want to just give you the introduction of that what is field. So in general term, the field meaning is the distribution of any physical quantity in the space. The field describes that in which manner particular quantity is distributed in the particular space or particular region. Now just come to electric field, as it is co-linked with the charge particle. So that is the particular, let's suppose if any charge is there, just for concept purpose I am just taking a positive charge. So as we know that electric field is a general property of the charge particle. So the charge particle modified the space up to a particular limit. So the particular region or space around the charge particle in which the charge particle can exert a force on another charge particle, or it can experience a force by another charge particle. So that particular region, space surrounded by the charge particle is called electric field. So by the basic introduction I am just giving you here. Let's suppose if plus q charge is there, okay, and let's suppose this is the particular region, okay, up to which it fields exist, okay. If any another charge particle, just for example I am just taking another charge particle q. So if this particular charge particle is just coming in the range of the field of this particular charge, so that particular charge will experience a force due to this particular charge. So that particular range up to which the charge particle can exert a force on another charge particle is called electric field. Now the electric field is correlated with the force. This is very important criteria, that field is correlated with the force. In the general term I am going to explain you. Just see here. According to the field property, the charge exists basically of two types. One is the source charge and another one is test charge. The source charge is that particular charge which is producing the field, and the test charge is a charge which will experience a force due to the source charge. So there are basically two kinds of the charges, as we know, that source charge and test charge. Source charge is that particular charge which is producing a field. So for example I am just taking this plus q charge which is just producing a field, okay. So let's suppose this is somewhat the range of this particular charge, and in this particular range if another charge which is used for just testing purpose, here the significance of test charge is nothing, its magnitude is very low, and it is just used for the testing purpose, that whether field is present or not. Let's suppose if the test charge with a very low magnitude is present inside the field of source charge, then definitely it will be experience a force due to that particular source charge. So if that particular test charge is experiencing a force, it means the field of source charge is present up to a certain limit or up to a certain range. So that particular range or limit up to which the test charge will experience a force is called electric field, okay. As we know that the charge, whether it is static or moving, always produces the electric field. So it is valid for both the cases, but here in electrostatics our consideration is only that the charge at rest. We are going to study some fundamental things when the charge is at rest, okay. Now I want to explain you that what is the meaning of electric field strength, okay, and what is the electric field intensity. So both terms are same. You see here that what is electric field intensity. Or electric field strength. Okay, for describing it, I am just considering, let's suppose one positive charge is there and inside it field one test charge is there. Always you need to remember that test charge is taken as a plus Q naught. Okay, this is the standard by default test charge which we generally use, plus Q naught, which magnitude is tends to 0, means it is just near to 0 and its significance is just for testing purpose. Means if we are using a test charge, so its magnitude is negligible and it is using for just testing purpose that whether field is present or not. Means if it will experiencing a force, it means that field is present, so for that purpose only we use this test charge. Okay, so just see here, let's suppose this particular test charge I am just taking here plus Q naught is placed inside the field. Now just see, let's suppose this particular plus Q naught charge is at r distance. Okay, inside the field is it at a small r distance. So from Coulomb's law we know that the force experienced by this particular charge Q naught is equals to F is equals to 1 upon 4 pi epsilon naught for the case of vacuum into capital Q into small q naught upon r square. That is the magnitude of the force by which it will be experiencing a force due to this particular source charge Q, where this is plus Q is a source charge and this plus Q naught is a just test charge. So now see here, this is a force. Okay, and the standard definition of the electric field intensity is just the force experienced by the test charge. Okay, the total force experienced by the test charge is called electric field intensity. Let me write in a standard term. I can write in this manner that E is equals to F upon Q naught, where the Q naught tends to 0. Okay, this is the standard definition of the electric field intensity, according to which we can just say the total. Let's suppose if I am just placing Q naught is equals to 1, if Q naught is unit, so if the unit test charge is placed inside the field, so whatever the force it is experiencing by the source charge, that particular force is called electric field strength. Means the field strength is just a force. Okay, it is describing the intensity of that particular force which is producing by that particular source charge. So now just see here, by this formula we can conclude the total force experienced by the unit test charge inside the field is called electric field strength. You see on the board here, if I am just describing this particular formula, that E is equals to F upon Q naught, and let's suppose if Q naught is 1, Q naught is unit, it means the total force experienced by the unit test charge which is placed inside the field is called electric field strength. So field strength is related to force. More the force experienced by the test charge, and it will be called that field strength is high. The less charge if it is experiencing, it means the field is weak. So when the field strength is high, when the field is enough strong, when the force is experienced by the charge particle which is called test charge particle is more. Okay, so let's suppose if at same distance, two same test charge is placed, so if the force is greater, it means its field strength will be greater. Now let's suppose if I need to write the unit of this particular E, so what will the unit? E is equals to F upon Q naught. The fundamental unit of this force is Newton, and for charge Coulomb. So for unit of electric field intensity is just Newton per Coulomb. Okay. One more thing is there. Okay. I want to just give you one more formula for this electric field intensity due to this particular point charge. Here, what is the significance, what is the meaning of point charge? Let's suppose if any particular charge is placed in a particular location of any space, in a fixed location which can be described by the x, y or z coordinate. So, that particular charge is called point charge, like this. If plus q charge is placed here, so due to this plus q charge, if I need to find the electric field intensity, so now see here, the formula of E is F upon Q naught, and what is the formula of F? That we have calculated 1 upon 4 pi epsilon naught Q naught upon R square. So now see here, E is equals to the value of F I am writing here, that is 1 upon 4 pi epsilon naught Q naught upon R square and upon Q naught. So Q naught will cancel out, and E formula is equals to 1 upon 4 pi epsilon naught Q upon R square. This is the basic electric field intensity formula for the point charge. Let's suppose if plus Q charge, which is the source charge, is placed at a particular point, and we need to find the electric field strength at the small r distance. Okay, so we can use this particular formula. Now, as we know, electric field intensity is a vector quantity, so we need to find the direction also, because it's a vector quantity. So this formula just gives you the magnitude, but for the direction finding application, see how to find the direction. Okay. One important thing I want to just discuss, the Coulomb force is a central force, okay, and the central force are the special kind of the forces which always directed towards a line which is joining the particles. Let's suppose if this particular line, that is called the central line, and if the force is applicable on this particular line, then it is called central force. Okay, means if the 2 points are there, so whatever the minimum separation is there, so on that particular line that force will be applicable. So you see here, according to the nature of charge, we can just give the direction of electric field. Okay, let's suppose this plus Q charge is there, okay, and inside its field, if the positive charge is there, then definitely there will be repulsion. So now the repulsion will feel or experienced by the test charge only. The plus Q charge will remain on its own position, but the force will be experienced by the test charge, which is used for the testing purpose. So let's suppose if this particular charge is repelling this particular charge, then it will move away from this central line, and the direction of electric field will be in this particular central line. So now this is the direction of electric field for this particular case. Okay. In a place of this plus Q naught, let's suppose if I am using minus Q naught, then what will the scenario? Here two opposite charges, and as we know that opposite charges always attracts, then definitely this source charge will create the effect of this particular test charge. Always just remember, whatever the result will be there, that will be for the test charge. Source charge will just act. Source charge is the acting here on the test charge. So whatever the attraction or repulsion, that will be experienced by that particular test charge, and according to which will we give the direction of electric field. Okay. So let's suppose that the positive and negative charge is there, then this charge will attract along the central line. So these are the basic things. Okay. Electric force, which is called electrostatic force, is a central force. Okay, electrostatic force is a central force, means the direction of attraction or repulsion will be along the line which is joining the two charges. This is very important thing. Okay, so this was our just basic concept of electric field, that what is the meaning of electric field, that I have explained only. In the next section, I am going to explain you that what is the field pattern for the positive charge and what is the field pattern for the negative charge and how they interact. Okay, so stay tuned to our channel. Thank you.